Good afternoon, guys. Welcome to the 35th lecture of fluid mechanics. We are in the unit 3. So we are discussing. So we are in the unit 3. So we are discussing the topic of smooth and rough boundaries when there is a turbulent or viscous flow. Nature is available in the pipe. So
transfer చేయండి
because of some technical issues, I've preponed the class 1 hour before. So as I'm having your seniors exams are going on in the next week, so we have to revise the subject for your seniors, 4th year seniors. So that's why your class has been preponed to 1 o'clock. So maybe tomorrow till Saturday the class may be preponed to, will start at 1 o'clock maximum, right? So be available and have your food early, right, before 1 o'clock, so that we'll have a class in a positive way, right? Okay. So right, so joining, some people are joining. Okay. So in the last class we have discussed about the derivations of smooth and rough boundaries. So what is the meaning of hydrodynamic smooth boundary and what's the meaning of hydrodynamic rough boundary? So if the thickness K is less, if the thickness K is more, we can differentiate the smooth and rough boundaries for turbulent flow of water, right? Next. So today we discuss about, so these are the derivations what we have discussed yesterday. So these are the formulas. So what okay, so these are the problems what we have this formulas what we have seen yesterday. Based upon these formulas, now we will discuss some of the problems associated with this formulas, right? So the velocity distribution of smooth pipes, the velocity distribution of rough pipes, the Reynolds number is equals to U star into K by V, right? So like this, we have some of the formulas which are related to the questions, right? Okay. So now we'll see the problems what we have discussed yesterday. So now here the pipe is given is as a rough pipe, right? The pipe of diameter is 8 centimeters. The velocity of pipe is 3 centimeters. The velocity at a point 3 centimeters from the wall is 30% more than the velocity at a point 1 centimeter from the pipe wall. Determine the average height of the roughness. So మనం K కనుక్కోవాలి. In this situation, we have to find the value K. అంతే కదా, మనకు ముందు ఇచ్చిన దాంట్లో we have to find the K value, right? So determine the average height of the roughness. Roughness means K. Average height means K. If this smoothness is also K, roughness is also K, but the average height is nothing but a K. Now what is given according to the question? The diameter of the rough pipe. So the rough pipe, for example, if you see the pipe here, the thickness of pipe like this, okay, the cross section of the pipe. So inside the wall, the pipe is having some sort of roughness, which it can be seen only through microscope. So physically we cannot see the roughness inside the pipe wall. Only through the microscope you can see the roughness. The roughness index ఎలా ఉంటుంది? So we have seen the figure like this, right? So we are having some zigzag, smooth flow or rough flow like this. You can see the roughness of the pipe. Now the roughness diameter of the pipe is 8 centimeters, that is 0.8 meter. Now what is the velocity at a point 1? The velocity at a point 1 is the velocity at 1 centimeter of pipe is mu. The velocity at 1 centimeter of pipe is, yes. Someone raised a hand. Ramesh, any doubt? Okay, if you don't have a doubt, just lower your hand. The velocity at a point 3 centimeters from a wall is 30% more than the velocity at a point 1 centimeter from pipe wall. So here the velocity is not given, only the distance from the pipe wall at 1 centimeter is given. Therefore, the velocity at a flow of 1 centimeter pipe wall is, let us assume, velocity u. The velocity at 3 centimeters pipe wall is the velocity into 1.3, right? Velocity into 1.3. Now, the velocity distribution of a rough pipe is given. So already we have derived the equation, that is u by u star. So this is a formula for the rough pipe. So u by u star is equals to 5.75 into log 10 into y by k plus 8.5, where k is the height of the roughness. So with this formula, we have to find the value of k. So by taking the initial velocity at a flow at 1 centimeter, we have u by u star is equals to, take this formula like this. So here at 1 centimeter distance, 1 by k plus 8.5. Substitute here value y, here that is 1. So why? Because it is at 1 centimeter pipe, right? Now, so this is 1, take it as 1. Okay. Now, from a point 3 centimeters from pipe wall, velocity is 1.3 into u. 1.3 into u. Now, 1.3, what is the initial velocity? 1.3 u by u star is equals to, same formula, 5.75 into log 10. So y place locala, write 3 by k plus 8.5. So assume this as 2, equation 2. Now, dividing 2 by 1, dividing the equation 2 by 1, we are getting 1 by 3 is equals to, so dividing 2 by 1. So 5.75 into log 10, 3 by k plus 8.5 divided by 5.85 log 10, 1 by k plus 8.5. So u star ఏమైంది, it has been cancelled, right? So this has been cancelled, u star and u star has been cancelled. So now this is a thing we have to derive. Now this can be converted as, so cross multiply చేస్తే 1.3 into 5.75 log 10, 1 by k plus 8.5 is equals to the right hand side also. So upon solving this line step by step, we are getting this equations, right? So this is equals to this. Next, then upon solving, we are getting, so log anni oka side veskondi, right hand side, okay, take the values. Now log is on left hand side, right hand side you are having the normal values. Now, so 7.475 into log 10 minus log 10k. So log 1 by k ante log 1 minus log k. So I mean normal basic fundamentals you have to keep in mind, right? Log 1 minus log k into 5.75 log 3 minus log k is equals to minus 2.55. Now 7.475 log 10 log 1 is equals to, you have to take the calci. So taking the calci, calculating log 10, 1 is equals to 0. So log 10k as it is, minus 5.75 log 3, that is 0.471 value, and log k minus 2.55. So upon taking log k one side, minus 7.4745, this one. So this into this 0 kabatti, ee rendu multiply chesthe you are getting this one. So this one into this one we are getting this one, and 5.75 minus into minus plus 5.75 log 10k minus 2.55. Therefore, ఈ రెండింటిని మనము మైనస్ చేస్తే we are getting minus 1.725 log 10k is equal to, so దీని రైట్ సైడ్ తీసుకొచ్చేసి 2.7433 minus 2.55. So that is the value you are getting. Therefore, log 10 log k is equals to, so divide this, take this value downside, so you are getting the value 1.88. So therefore k is equals to log inverse 1.88 is equals to 0.7726. Therefore the average height of the roughness is 0.7226. So like this you have to solve the problem when you get any rough pipe or smooth pipe diameters, right? So they will give the two instance, that is at velocity of point one section and the velocity of point at the other section. So by taking those two values, మీరు divide చేసుకొని, so you have to calculate the value of k. Hope you understood this problem. So in this third unit, the problems are very, very lengthy, and you have to use formulas according to the question given. Okay, na? So that's why I have said earlier. So every unit low, whatever the topics we are discussed in now, unit 1 and unit 2 and unit 3. So every unit formulas మీరు separate గా రాసుకొని పెట్టుకోండి. So that unit 1, so these are the formulas comes in the unit 1. Unit 2, these are the formulas comes in the unit 2. Unit 3, these are the formulas. So that's why I've written some of the formulas for unit 3, right? So make easy to understand avvadaniki. Next we'll see the problem 3. Why? Because in the unit 3, majority 80% you expect problems only. Okay, na? One derivation or one problem and one short answer question. Now see here. A smooth pipe of 800 long, a smooth pipe of diameter 80 mm, a smooth pipe of diameter 80 mm and 800 long carries water at a rate of 0.480 meter cube per minute. Calculate the loss of head, HF కనుక్కో. Loss of head అన్నప్పుడు you have to directly strike the mind, HF, right? Calculate the loss of head, wall shearing stress tau, center line velocity, velocity at the shear at 30 mm pipe wall. Also calculate the thickness of laminar sublayer, Take kinetic viscosity of water is 0.015 Stokes. Take the value of coefficient of friction, F from the relation as given as. So ఇక్కడ మనకి F value already మనకి ఇక్కడ ఇచ్చారు. F is equals to 0.0791 divided by RE 1/4, where R is equals to Reynolds factor. So this F, so I have written here, this one, see here. So it's already manaki formula, but they have given in the question itself. So here 0.0791 divided by RE 1/4 onto the turbulent flow is for smooth pipes, and we have to analyze. You have to keep in mind. Okay. Now what is the given data? The diameter of the smooth pipe. The diameter of the smooth pipe is D is equals to 80 mm. So convert into meter. Now the length of pipe is equals to 800 meters. Now what is the discharge? The rate of discharge. Discharge in ఎలా తెలుస్తుంది? If it is a meter cube, then we have to assume the rate of discharge Q. Q is equals to 0.048. So దాన్ని seconds లో కన్వర్ట్ చేసుకుంటే 0.48/60, that is equal to 0.008 meters cube per second. And what is the kinetic viscosity given? The kinetic viscosity V is equals to 0.1015 Stokes. Kinetic viscosity is 0.015 Stokes. That is equals to, convert into meters square per second, 0.015 into 10 to the power of -4. Stokes అంటే ఏంటి? 1 Stoke is equals to centimeter square by second. So దాని meters లో చేసుకుంటే డబల్ వస్తుంది కాబట్టి 10 to the power of -4 meter cube per second. So if in the exams, if you don't know the conversion, so whatever the calculations you do, maximum you try to do the process. Okay, process తెలిస్తే చాలు. If you are not converting like this, so 0.015 Stokes చేశారు అనుకోండి, సో వాల్యూస్ అనేది మీకు ఆటోమేటిక్ ఆన్సర్ వచ్చేసరికి చేంజ్ అవుతుంది. But don't think that it is not correct answer. If your process is good, మీరు కరెక్ట్ గా ప్రాసెస్ గా చేశారంటే you'll score the marks. Then what is the density here? Water we are using కాబట్టి, then automatically we have to take the density 1000. Then what is the mean velocity? So మనకి diameter, length, area వచ్చింది కాబట్టి the mean velocity V is equals to Q by area. What is Q? You know already. And what is the area? 5d square by 4. So 0.8 square by 4 is equals to V is equals to 1.591. Then what is the given data is given? The shear stress is given. Okay. Then what is the Reynolds number? The Reynolds number RE is equals to V into D divided by V. Right? So keep the velocity what you got here. So you keep the velocity రాయండి into this one divided by 0.15 into 10 to the power of 4. That is equals to 8.485 into 10 to the power of 4. Okay, na? So once you got this Reynolds number, as a Reynolds number value and the more than 10 to the power of 4 ఉంది కాబట్టి more than 4000, the type of flow is turbulent, though in a smooth pipe. Now Now taking the value of f, already given the f value. So re value వచ్చింది కాబట్టి, so f question already ఇచ్చారు కాబట్టి, so substitute re here. So substituting re, so you are getting the value of this one, right? Now start doing. So ఏం అడిగాడు? Take the value of coefficient friction. Okay, calculate the thickness of laminar sublayer, take the viscosity, calculate the loss of head, wall shearing stress, central line velocity, velocity under shear stress. So what is the first one? Head loss. Head loss is given by the equation. So this is the equation what you have to keep in mind. Equation already నేను మీకు ఇక్కడ ఫార్ములాస్ లో మెన్షన్ చేశాను. See here, see this one, the equation, right? So that's why మీరు ఫార్ములా సపరేట్ గా రాసి పెట్టుకున్నారంటే it will be easy for your exam point of view. Therefore substitute the value 4 into f value already మనం తీసుకున్నాము into L is equals to 800, V is equals to 1.5 square divided by diameter is 0.08, 2 into G 9.81. So the head loss is equals to 23.42 meters. Everything should be in meters. Okay, na? Therefore the value is 23.42. And what is the next thing you have to find? Wall shearing stress, tau 0. So the tau 0 is the value, the formula is tau 0 is equals to f into rho into v square by 2. Therefore f value మనకు already వచ్చింది కాబట్టి substitute f value into tau is equals to 1000 because density is water divided by 2 into v square 1.59 square. The value is 5.866. Now the center line velocity, u max, center line velocity. So these symbols, the notations you have to keep in mind. Center line velocity u max, shear stress tau 0. So for smooth flows is given by the formula. So center line velocity formula, this one, u by u star is equals to 5.75 log 10 into u star into y by v plus 5.55. Now substituting those values, so ఇక్కడ మనము ఇది కనుక్కోవాలి. So u star that is equals to root of tau naught by rho. So that's the tau naught is equals to 5.866, which we have already got, divided by 1000. The value is this one. Now the velocity will be maximum when y is equals to d by 2. So here if my y వచ్చింది కదా, so for this one y is equals to d by 2. Therefore 0.04 meter, the velocity will be maximum. Therefore hence at y is equals to 0.04, u is equals to u max. Substituting values all in this one equation 1, u max by u star, this is the u star, that is shear velocity, u max by shear velocity is equals to 5.75 log 10. So this u star into y by v, so this u star, this one, right, 0.0765 into v is equals to 0.04 divided by v in plus 5.55. So then start doing the simplification. 5.75 log 10 plus, then calculate చేస్తే మనకి ఇంత వచ్చింది plus 5.5. Therefore 5.75 into, so దీన్ని మీరు calculate చేస్తారంటే you get the value. So therefore 24.58. Therefore u max is equals to 0.765. ఈ వాల్యూ అంటే దీని కింద ఉంది కాబట్టి ఇది ఇటు వెళ్తుంది. So 0.0765 into 24.58. The value is 1.88 meter per second. So that is a central line velocity u max. Then what is the next thing you have to find? The shear stress at a point. The shear stress at a point, tau is equals to minus dp by dx r by 2. Now what is the r here? R, you know, d by 2, where the hence shear stress at the pipe wall, where r is equals to r. Therefore tau naught is equals to minus dp by dx r by 2. Thereby dividing the equation 1 is ఉంది కదా, so this a divided equation by b, tau by tau naught is equals to, so you cancel out కాబట్టి this one will get cancelled. So you are getting tau by tau naught is equals to r by R. Now the shear stress is equals to tau is equals to tau naught into R divided by capital R. Now at a point 30 mm, question law you are given at a point 30 mm from the pipe wall is having R is equals to 4 minus 3, that is 0.1 meter, right? Therefore, tau at R point, so in the Ray's awesome level, if you know the concept, you can write directly. So at this 0.01 meter, tau is equals to tau naught into 0.01 by E values, right? Tau naught into 0.01 by 0.04. So that is the value is this one. Now the velocity at 3 centimeters. Now the velocity at 3 centimeters, and so the V y becomes 0.03 meter. Velocity at 3 centimeters from the pipe wall. Therefore, applying the same equation, U star by U by U star is equals to 5.75 log 10 U star into V y by V plus 5.5, where U is equals to already మనం చేసాము, y is equals to 0.03. Now substituting this one, U by U star is equals to 5.75 into log 10. Substitute those values. U star value రాయండి, y value రాయండి, v value రాయండి, plus 5.55. Therefore, upon simplifying, you will get this value. తర్వాత 0.75 into 23.86, that is 1.825. Therefore, U is equals to 1.825. Then what is the next question given? So this type of question will be given for 15 marks or 8 marks. So pattern change అయింది కాబట్టి 7 marks, 8 marks. 7 marks ఒక డెరివేషన్ ఉండొచ్చు, 8 marks ఒక ప్రాబ్లం ఉండొచ్చు, లేదంటే 2 ప్రాబ్లమ్స్ ఇస్తారు. Next, the thickness of sublayer is given by tau dash is equals to 11.6 into V by U star. This is the formula. Okay. Now 11.6 into V కనుక్కున్నాం కాబట్టి 0.015 into 24 of 4 U star value. Therefore, tau is equals to, after substituting, you are getting a value 0.02274. So if you don't know the process, so whatever the things you got in the mind according to the problem, our formulas వేసి, so maximum try to do solving the problem. So మీకు ఈ ఫార్ములా తెలియదు అనుకోండి, start doing up to this one only. So ఇంత మీకు తెలియదు అనుకోండి, start doing up to here only. So maximum try to do the problem whatever you know. So if the question, so this is the question which you will get for 8 marks, or if the problem is for 15 marks, okay question వస్తుంది. Or if you are getting 2 marks, 7 marks, 8 marks. So ఈ ఒక్క క్వశ్చన్ వచ్చిన maximum first thing write the given data correct గా మీరు రాసారంటే you will get 2 marks. Then what are the formulas, what is the next aim కనుక్కోవాలి. So what is the thing to calculate? Loss ahead question mark పెట్టండి, wall shearing stress question mark పెట్టండి, central line question mark పెట్టండి. So given data తర్వాత next what to find అని పెట్టేసి ఇవన్నీ పెట్టి question marks పెడితే definitely you will get 1 mark or 2 marks. Next, write some formulas, do some process, దానికి మీరు చేసిన దానికి ఒక 2 marks. So like this you will get minimum out of 8 marks. So minimum you will get 5 marks even though you don't write the final answer. అంటే మీరు చేసే పద్ధతి they require, not how the question answer you, how correctly you are getting the answer. Why? Because మీరు నోటేషన్, మీరు ఈక్వేషన్స్ సెంటీమీటర్స్ కన్వర్షన్స్ చేయలేదు అనుకోండి, ఆటోమేటికల్లీ ఆన్సర్ అనేది ఒక్కొక్కరికి ఒక్కొక్కలాగా వస్తుంది. సో దట్స్ వై డోంట్ సీ పర్టికులర్లీ ఆన్ ద ఫైనల్ ఆన్సర్. సో ఫస్ట్ థింగ్ ఈస్ హౌ వెల్ యు ఆర్ డూయింగ్ ద ప్రాబ్లమ్, ఏ ఫార్ములాస్ ఎక్కడ అప్లై చేస్తున్నావు, దట్ ఈస్ వెరీ వెరీ ఇంపార్టెంట్. ఓకేనా? So if you have any doubts in the middle, just try to communicate with me either by message or by speaker. అర్థమవుతున్నాయా ప్రాబ్లమ్స్? Anyone in the group? Just pass the message. అర్థమవుతున్నాయా? Anyone? For understanding? I need some information from your side.
Yes, sir.
Okay, Riyad Sheikh. Still any other? Manohar, Naeem, Falguna, Snehalata, Shravani. Girls, are you understanding the problems? Okay. Okay. Yes, I understand. Yes. అయిపోయింది కాబట్టి you have to say yes sir, I understood. Understand means continuous present tense. Understanding కంటిన్యూస్ జరుగుతుంది. చెప్పేసాం కాబట్టి I understood. Okay. Okay, that is not a problem. Right. So why? Because this subject is purely theoretical. This subject is purely mathematical. So I am taking the subjects for your seniors and super seniors also, your third years and fourth years. So there the subjects are 70% theory and 30% problems. Though there చెప్పుకోవడానికి చాలా ఉంటుంది, మ్యూచువల్ కన్వర్జేషన్ ఉంటుంది. అక్కడ కొన్ని డౌట్స్ వస్తాయి, కొన్ని స్టూడెంట్స్ కొన్ని నేను వర్క్ ఇస్తాను, అసైన్మెంట్ లాగా ఇస్తాను, చేస్తారు. బట్ హియర్ దేర్ ఇస్ నో ప్రాసెస్ ఆఫ్ డూయింగ్ లైక్ దట్, ఓన్లీ వన్ వే. సో దట్స్ వై ఇఫ్ యూ గాట్ ఎనీ డౌట్, రైజ్ యువర్ హ్యాండ్, ఆర్ యూ వాంట్ టు టాక్, జస్ట్ ఓపెన్ యువర్ మైక్ అండ్ టాక్ టు. సో ఇది చెప్పేటప్పుడు అర్థమవుతున్నట్టే ఉంటుంది. మీరు మళ్ళీ ప్రాక్టీస్ చేసేటప్పుడు పేపర్ పెన్ తీసుకొని మీకు కొన్ని అనుమానాలు వస్తాయి. దట్స్ వై క్లాస్ కంటిన్యూటీ ఉండాలి. అట్ ది సేమ్ టైం ఫ్రీ టైంలో మీరు చిన్న చిన్న ప్రాబ్లమ్స్ సాల్వ్ చేసుకుంటూ వెళ్ళండి. రైట్. సో దిస్ టైప్ ఆఫ్ ప్రాబ్లమెటిక్ సబ్జెక్టు పాస్ అయితే పాస్ అవుతారు, లేదంటే ఫెయిల్ అయిపోతారు. వస్తే స్కోర్ వస్తుంది, ఎలా రాశారో తెలియదు, బట్ హై మార్క్స్ వస్తాయి. లేదంటే ఏదో రాసినాం సార్ బట్ మాకు ఫెయిల్ అవ్వలేమని ఈజీగా చెప్పేస్తారు. చాలా మొత్తం బుక్ అంతా నింపేసాం, బుక్లెట్ అంతా, బట్ ఐ హ్యావ్ ఫెయిల్డ్ అంటారు. రైట్. ఓకే. So why? Because if you see my other classes for your seniors, third years and fourth year, the total subject is different. Okay, now that's why the examples, the real time examples, కొన్ని కేస్ స్టడీస్ తీసుకొని చెప్తాను. అవి ఎఫెక్టివ్గా ఉంటుంది వినడానికి. సో వాళ్ళు కూడా నాకు రిప్లై ఇస్తారు. ఇక్కడ ఓన్లీ వన్ వే కాబట్టి ప్రాబ్లమ్స్. సో దట్స్ వై ఐమ్ ఆస్కింగ్ యూ ఫ్రీక్వెంట్లీ. సో మీరు కూడా రెస్పాండ్ అవ్వండి. ఈవెన్ దో యు ఆర్ స్లీపింగ్ అండ్ లిజనింగ్ ఆర్ ఈటింగ్ అండ్ లిజనింగ్, వాట్ ఎవర్ యూ డూ, బట్ డౌట్స్ వస్తే జస్ట్ ఆస్క్. ఓకే. So we are discussing the next type of problem. Determine the wall shearing stress. Determine the wall shearing stress in a pipe of diameter 100 mm which carries water. So first line lo manaki the diameter is given, the liquid is water. So 1000, rho is equal to 1000. The velocities at the pipe center is 30 mm from the pipe center, or the velocities at the pipe center and 30 mm and from the pipe center are 2 meters per second and 1.5 meters per second respectively. So the velocities are 2 meters per second and so y అనేది వస్తుంది. ఇట్లా క్వశ్చన్ వచ్చింది అనుకోండి ఫ్రమ్ ద పైప్ అనేసి, సో యూ హ్యావ్ టు అజ్యూమ్ y ఫార్ములా అంటే లాగ్, అలాంటి ఫార్ములాస్ వస్తాయని యూ హ్యావ్ టు కీప్ ఇన్ మైండ్. దెన్ ద ఫ్లో ఇన్ ద పైప్ ఈస్ గివెన్ యాస్ టర్బులెంట్. సో ఆల్రెడీ క్వశ్చన్లో ఇచ్చేసాడు, ద ఫ్లో ఈస్ టర్బులెంట్ అనేసి. Now what is the given data? The diameter of the pipe. Write the given data, whatever it is there. So దీనికి ఒక 2 మార్క్స్ వస్తుంది. What is the thing you have to find? So దానికి ఒక 2 మార్క్స్. That's why అలా మీరు చేసుకుంటూ పోతే ఈజీలీ యూ కెన్ స్కోర్ ద మార్క్స్. లైక్ సెకండ్ సెమిస్టర్ 2-2లో కూడా యూఆర్ హ్యావింగ్ హైడ్రాలిక్స్ అండ్ మిషనరీ సబ్జెక్ట్. సో ఇప్పుడు మీకు సీనియర్స్కి ఇలాంటి టాపిక్సే జరిగింది, బట్ ఇన్ ద క్లాస్ దే హ్యావ్ గివెన్ ద ఎక్సలెంట్ రెస్పాన్స్. ఎందుకంటే లాస్ట్ సెమిస్టర్ క్లాసెస్ ఐ టుక్ అరౌండ్ more than 60 classes or 70 classes. So excellent response from your seniors. గోల చేస్తున్నా కూడా more than 60 అనుకుంటా, more than 66 ఉన్నారు your seniors, but the response is good from the girl side and from the boy side also, right? About the problems, about the concepts. So మీరు కూడా అట్లా మీరు your class అలా ఎలివేట్ అవ్వండి, right? Next, the diameter of the pipe D is 100 meters. Convert into meters. సో కన్వర్ట్ ఇంటూ రేడియస్. ఇవన్నీ ముందు జాగ్రత్తగా చేసి పెట్టుకుంటున్నాం, రైట్? సో కొంతమంది ఏం చేస్తారంటే సమ్ స్టూడెంట్స్ విల్ డూ ద ప్రాసెస్, ఆ టైంకి వచ్చిన తర్వాత కన్వర్షన్ చేసుకుంటారు. కొంతమంది ముందుగానే కన్వర్ట్ చేసి పెట్టుకుంటారు. దట్ ఈస్ దేర్ స్టైల్ ఆఫ్ డూయింగ్ ద ప్రాబ్లమ్స్. నెక్స్ట్, క్యారీస్ వాటర్. ఓకే, ద వెలాసిటీ ఆఫ్ ద పైప్, దట్ ఈస్ నౌ ద వెలాసిటీ అట్ ద సెంటర్ U max is 2 meters per second. The velocity at the center is 2 meters per second. The velocity at 30 mm, the velocity at 30 mm is, or the velocity at 30, ఇక్కడ మళ్ళీ కన్వర్షన్ అయిపోయింది, or 0.03 from the center is 1.5 meters per second. Center కింద from the velocity from the center is 1.5 meters per second. Now the velocity at r 0.03 meters, U is equals to, take this one as initial velocity 1.5 meters per second. Therefore let the wall shearing stress. So tau naught అని ఎలా మెన్షన్ చేస్తున్నాం means tau naught is equals to wall shearing stress. Therefore the turbulent flow, the velocity distribution for the turbulent flow, the velocity distribution in terms of center line velocity u max is given by the equation this one. U max minus u by u star is equals to 5.75 log 10 capital R by y. So ఈ ఫార్ములా ఆల్రెడీ నేను మీకు రాశాను, తర్వాత మీరు చెక్ చేసుకోవచ్చు, నో ఇష్యూస్. వేర్ the given data u is equals to 1.5, y is equals to capital R minus small r, that is equals to capital R is 0.05 minus 0.03, that is 0.02. సో మనకి R వాల్యూ వచ్చేసింది కదా. సో capital R minus small r, that is 0.03, that is y is equals to 0.02 value. Now substituting those things here, u minus u max divided by u star is equals to 5.75 into log 10, 5.75 into log 10 capital R by y. So capital R by y. Substituting, you are getting this value. Upon substituting, you are getting u star is equals to 0.05, 2.288, that is equals to this one. Now by using the relation this one to find the shear stress, u star is equals to root of tau naught by rho, where rho is equals to water. Now apply the value, u star value, tau naught kanukkoli kabatti, so tau star keep aside and simplify these values, you are getting 47.676 Newton per meter square. That is the wall shearing stress. Wall shearing stress ki notation tau naught. Okay na? So therefore in order to find the tau naught, so this is the formula, u star is equals to root of tau naught by rho. So like this you have to solve the problem for this situation. So ikkada manaki problem chinnaga undi, right? So manaku only okate kanukkomannadu. So that's right, you have to find only determine the wall thickness and shear velocity, shear stress. Okay, now we'll see, actually this derivation exam ki raadu, but the formulas ela unnayo just we'll discuss, because the time is also very less, 5 minutes. I didn't have my lunch. Once class ayin tarvata again at 2 o'clock I have the seniors class. Okay, so the velocity distribution for turbulent flow in terms of average velocity. ఇప్పటి వరకు మనం తీసుకుంది the various types of stresses, right? So the wall stresses, the smooth flow and rough flow wall stresses. Here we'll see about the average velocity, how the turbulent flow is acting with the velocity distribution. So this is a front view, this is a front view of the pipe, this is a side view of the pipe, or you can assume this is a side view, this is a front view. So here it is given as the elementary object of a circular ring. So from the center the R, the balance is a Y, the total is the radius of the pipe. The flow is moving from this side to this side. So if you see, this one is a radius R, that is a dr. So the total radius is capital R. Now the average velocity u bar through the pipes is obtained by first finding the total discharge Q and then dividing the total discharge by the area of the pipe. So దీన్ని మీరు సింప్లిఫై చేసుకుంటూ వెళ్తే, ఐఎమ్ నాట్ డిస్కసింగ్ టోటల్ డెరివేషన్. సో కీప్ ఆన్ చేంజింగ్ dq, area of the ring into velocity, area of the ring into velocity. Therefore what's the area of the ring? 2 pi r dr into u. Velocity is u, therefore u into 2 pi r, just conversion chesadu on the dr. Now the total discharge Q is equals to integral of dq discharge, dq is equals to 0 to radius u into 2 pi r dr. So smooth pipes key, so you're having smooth pipe and rough pipe. So for smooth pipe, so if you are taking this one, the formula what we have already discussed earlier, 10.20, that is taking this one into consideration, u is equals to 5.75 log 10 u star into y plus 5.5, just u star ikkadiki vastundi. Then but here you know that y is equals to capital R minus small r. Therefore u is equals to y plus lopala, ఇది substitute చేయండి లోపల. Therefore like this you will get the thing. Then substituting this one, the equation 10.22 we get, ఈ ఈక్వేషన్ లో మీరు సబ్స్టిట్యూట్ చేసిన తర్వాత ఈ ఈక్వేషన్ లో Therefore, Q is equals to U substitute చేయండి ఇక్కడ substitute U here. Therefore, substituting total U into 2 pi r dr. So దీన్ని substitute చేస్తే keep on substituting. The average velocity you are getting here is U star U bar by U star is equals to 5.75 into log 10 U star into R by V plus 1.75. Right? This is the average velocity in the smooth pipe. The smooth pipe. Now, if you take for the rough pipes, so rough pipes manaki formula idi telusu manaki. So this is the formula for rough pipes. So దీన్ని కన్సిడర్ చేసుకొని the average velocity మనం కనుక్కుంటే apply the same process. Y is equals to r minus r. So y place లోపల ఇక్కడ substitute చేయండి r minus r by k. Now keep on substituting u is equals to u star. ఈ value వేసేసేయండి. Then substituting the value of u in the equation 10.22, right? Now we are getting q is equals to same this into 2 pi r dr. So then keep on substituting this one, the average velocity. The formula for the rough pipe is u star u bar by u star is equals to this formula. Okay, for the smooth flow, for the rough flow. ఈ formulas already నేను మీకు ముందు ఆ yellow paper మీద already I have written the formulas. Now the average velocity for the smooth pipe, the average velocity for the rough pipe formulas are already mentioned here. Now the difference of the velocity at any point, and the average velocity for smooth and rough pipes, and taking this both values, the smooth for the smooth pipe and the rough pipe, the difference of the velocities, the average velocity at any point in the pipe can be given as u by u star is equals to 5.75 log 10 u star r minus r by v plus 5.5. So the equation 10.23, this equation can be written as this one, like this. Dividing velocity of u and u bar for smooth pipe is obtained as, so upon keep on deriving this equation, so u by u star minus u bar by u star, and this is u by u star minus u bar by u star. So then keep on మీరు simplify చేశారంటే, so taking u star as a common 5.75, taking aside k రెండిట్లో 5.75 కామన్ కాబట్టి ఈ 5.75 బయటికి తీయండి. So log 10 this one minus this one. Then keep on solving this one. See here. So log 10 బయటకు వచ్చింది 5.75. This into plus u star by r by v. So like this, keep on solving. You are getting the value slowly, and finally substituting the value of u at any point for the rough pipe is given by the equation this one. Though the average velocity of the equation of 10.24. So keep on changing this one. Finally, this is the average velocity. So you will not get question కాబట్టి I am not discussing the derivation. So this is a formula for average velocity at a point of rough flow or smooth pipe. So this is average formula. This one is for smooth rough pipes. This one is for smooth pipe. Okay, now. So you already this formulas have been written in the formula sheet. So from then in the next class we'll discuss these formulas and we'll do the problems. This one 10.5. So you're having number of patients or number of problems. Why I'm discussing means each problem is having different style. అందుకే నేను ఒక style తీసుకొని I'm solving one or two problems in that category, right? So like this we're having the problems. Tomorrow we'll discuss this balance problems. Okay, now. So we'll stop the class here. So I have a class for 4th years, right? Okay. So if you have any doubts, just don't hesitate to ask me, and later I will share this PPT for you also in your group. Okay, na? So thanks for listening to the class. So once this video is uploaded in the YouTube channel, so later the link is posted in your WhatsApp group. Share this link to other students, those who are not in the class.